So we looked at finding derivatives involving logarithmic functions, but the next 4 problems would deal with using logarithms to find derivatives. This is sometimes referred to as logarithmic differentiation. When to use it? When we have complicated functions within radicals, functions and exponents, multiple functions in product, and so on. So usually with practice, people would realize, okay, I've got to use logarithmic differentiation here. A key aspect of logarithmic differentiation is implicit differentiation. So that's it. Here is an example where we want to find the derivative of y equals x raised sine x. And you could see the function sine x is in the exponent. So that's what I meant by functions in exponents. So we have a case here, and taking the derivative in this case directly might be quite complicated. So what we do is we make use of logarithmic differentiation. So we take logarithm on both sides, we typically do natural logarithm. So natural logarithm of y equals natural logarithm of x raised sine x. So I take natural logarithm on both sides. Now, one of the properties of logarithm states, well, if I have a power, I can move it to the front. So I can move that sine x to the front and write it as ln of x. And if we remember from implicit differentiation, that is a function of y. So we have to treat it like a function of x and then multiply it by the derivative of y. So the derivative of ln of y is 1 over y, and we multiply by its derivative, y prime. Now, we like to take the natural logarithm because we don't want to multiply by another constant. In the previous video, we saw that if we had log base b of y, the derivative would be 1 over y, and you've got to multiply it by y prime and ln of b. And we don't have to do that here. On the right-hand side, we have a product of two functions, u and v. So we have to use product rule. U is sine x, and v is ln of x. U prime would become cosine x, and v prime would be 1 over x. So product rule is uv prime plus v u prime. Now we could go ahead and plug in the values that we found. So 1 over y times y prime equals u, which is sine x, multiplied by v prime, 1 over x, plus v ln of x, u prime cosine of x. There isn't much we can do in terms of simplification, so we have 1 over y times y prime equals sine x over x plus ln of x cosine x. So y prime would equal to y multiplied by sine x over x plus ln of x cosine x. But then realize that we already have y is equal to x raised sine x in that step, so we can replace that here. So y prime would be equal to x raised sine x multiplied by sine x over x plus ln of x times cosine x. And that would be the final solution. In this case, we know what y is exactly, which is why I'm making the substitution from that step over there. And I'm replacing y by x raised sine x, which I have already. So here is a problem which we can do it in multiple ways. We could actually use chain rule, but if we use chain rule, then once you get to chain rule, you'd end up using quotient rule again, and the process would get extremely complicated. So what we see here is a function that is inside a radical. So if I rewrote it, I would have y is equal to x plus 2 divided by x minus 2 raised 1 over 2. That's what the square root means. So I'm going to take ln on both sides. So I could make the process of finding the derivative simplified. So take ln on both sides, so we'd have ln of y equals ln of x plus 2 over x minus 2 raised 1/2 ln of y, again using the rule, the 1/2 would come to the front, we'll have ln of x plus 2 over x minus 2. You may, jump right away and say, oh, well, I could take the derivative at this step. Well, you can do that, but you would end up using chain rule again, which is going to result in quotient rule one more time, or it'll just show up because of the function that is inside the logarithm. So this is where another key property of logarithm comes into play. ln of y is equal to 1/2. If I have ln of x plus 2 divided by x minus 2, I could write it as ln of x plus 2 minus ln of x minus 2. And this is the reason why we have to understand the properties of logarithms, because it is going to make things easier for us. Or they are going to make things easier for us. So take the derivative of ln of y. We have 1 over y multiplied by y prime. equals 1 over 2. We have x plus 2, which is a function of x. So 1 over x plus 2 multiplied by its derivative, chain rule. Derivative of x plus 2 is simply 1, minus 1 over x minus 2, which is the derivative of ln of x minus 2, multiplied by 1. So we have 1 over y times y prime equals 1 over 2, 1 over x plus 2 minus 1 over x minus 2. Now you ask yourself a question, is there a way for us to simplify this? Looks like we can in this problem. If we take the common denominator, x minus 2 divided by x plus 2 times x minus 2, minus 1 over x minus 2 multiplied by x plus 2. So the common denominator is x plus 2 times x minus 2. Oh, I forgot to multiply it by x plus 2 there. So I have x minus 2 minus x minus 2. The x's will get cancelled. So I have 1 over 2 minus 4 divided by x plus 2 times x minus 2. The 2 and negative 4 will get cancelled. We get negative 2. 1 over y times y prime is equal to negative 2 divided by x plus 2 times x minus 2. Y prime would then equal to y times negative 2 divided by x plus 2 times x minus 2. And since we already know that y is x plus 2 over x minus 2 raised 1/2, I'm just going to plug that back in. So times negative 2 over x plus 2 times x minus 2. And that would be the final answer. If we can't plug in the value of y, if y is unknown, we leave y as is implicitly. We've seen that with implicit differentiation. But in this problem, though, we know in this one and the previous one, we know exactly what y is, and I'm able to replace the y that I get in my answer with the substitution that we had, or with whatever y that is given in the problem. So here is a case where we have a function, cosine of x, and it is raised to the power of x. So what we have is y equals cosine x, and a function, which is x, is in the exponent, so we have to make use of logarithmic differentiation. So take ln on both sides. So ln of y would equal to ln of cosine of x raise x. Using the power rule of logarithms, x is going to move to the front. So x times ln of cosine of x. Now take the derivative on both sides. We have 1 over y multiplied by y prime. because the derivative of ln of y is 1 over y, but y is a function of x, so we've got to multiply it by y prime. That is implicit differentiation. On the right-hand side, we want to take the derivative of x times ln of cosine of x. And that has two parts. So we have u, and then we have v. Which means we have to use product rule. So u is x, and v is ln of cosine of x. U prime is 1. V prime, we have cosine of x, which is a function, within ln, so we have to use chain rule. So 1 over cosine of x multiplied by the derivative of cosine of x, which is negative sine x. So u prime is 1 and v prime is negative sine x over cosine x, which is negative tangent x. That's just a trigonometric property. Now going back to this step, 1 over y times y prime equals, that derivative is u v prime plus v u prime. U is x, v prime is negative tangent of x. V is ln of cosine of x. U prime is 1. Y prime is 1 over y times y prime is negative x tangent of x plus ln of cosine of x. Multiply by y on both sides, we have y negative x tangent x plus ln of cosine x. But we know that y is cosine x raised x, so y can be replaced by cosine x raised x and multiplied by that term that is inside the square brackets. And that would be the final answer. Again, if you can substitute y back, we go ahead and substitute y back. But if we can't do that, we'll just leave it as is. So now we have to find the second derivative. We have y equals ln of x raised cosine x. Again, there is a function cosine of x in the power. So what we do is we take the natural logarithm on both sides. So ln of y would equal to ln of x raised cosine x. Using the power rule of logarithms, the cosine x is going to move to the front. And we have ln of x. As always, we take the derivative on both sides. We would have 1 over y times y prime equals d over dx. Cosine x multiplied by ln of x. So that is u and that is v. So u is cosine of x and v is ln of x. U prime is negative sine x, and v prime, we have to use chain rule because ln of x is inside the function ln. So we treat ln of x as x. So the derivative would be 1 over ln of x. But we realize that it is a function of x and not x by itself. So we multiply by its derivative. We have 1 over x. So 1 over y times y prime equals u v prime plus v u prime u is cosine x, v prime is 1 over x times ln of x, v is ln of x, u prime is negative sine x. So we have cosine of x divided by x ln of x minus sine x ln of x. And that would equal to y prime over y. So y prime would simply be equal to y times cosine of x divided by x ln of x minus sine x times ln of x. Trying to insert a page. Could I insert a page? Okay, I did. So I need extra space here because the second derivative is going to take a lot of space. So I am going to replace y, and if I replace y, I'd simply have ln of x raised cosine x multiplied by cosine x divided by x times ln of x minus sine x times ln of x. Great. Now we want to find the second derivative. Now this is a great problem for practice. So naturally you may say, well, I am going to go ahead and start at this step to find the second derivative. Now that is going to be complicated because we have a term here that is in product with this term, and that has a product here, a quotient there, and we need to use product rule there, quotient rule there. So things are going to get out of hand really fast. So what we're going to do rather is we're going to find the second derivative implicitly, like the way we found the first derivative. So we go back to that step right there. So I'm going to start with 1 over y times y prime equals cosine x divided by x ln of x minus sine x ln of x. So we have to take derivative on both sides. The left-hand side, we have u and v. So u would become 1 over y, which is y raised negative 1. V is y prime. U prime, we're going to treat y as x. So if we use the power rule of differentiation, we have negative y raised negative 1, negative 1. But we have to realize that this is not just y, not just x, rather y. We have to multiply by y prime, implicit differentiation. And v prime is simply the derivative of y prime, which would give us the second derivative of y. So if we use the product rule on the left-hand side, we have u, 1 over y, multiplied by v prime, y double prime, plus v, y prime, multiplied by the first derivative, minus y raised negative 2 times y prime. And that would equal to the right-hand side, d over dx, cosine x, x ln of x minus sine x ln of ln of x. Again, this is a challenging problem, and it's a great problem for practice. So I could write y double prime over y minus, I can write y raised negative 2 as 1 over y squared. Y prime times y prime is y prime squared. And on the right-hand side, we have that giant expression. So we have to take the derivative of the first term minus the derivative of the second term. So let's do this separately. So I'm going to start with the derivative of the first term, which is cosine x divided by x times ln of x. We have to use quotient rule. So u is cosine x, v is x ln of x, u prime would be sine x, and v prime, we have to use product rule again. I'm going to call that a, and that has b. So we would have a b prime plus b a prime. So a would be x, b is ln of x, a prime is 1, b prime is 1 over x, a b prime would be x times 1 over x, plus b a prime ln of x times 1. So we end up having 1 plus ln of x. So we're doing this so that we can find the derivative of that term. So d over dx cosine of x divided by x ln of x is equal to v u prime minus u v prime divided by v squared. So x times ln of x multiplied by sine x, which is u prime, minus cosine x multiplied by v prime, which we have derived as 1 plus ln of x, and the entire thing divided by x ln of x squared. We're not done yet. We still have to find the derivative of sine x ln of x. We might need another page, so let's go ahead and add another page. So we have u multiplied by v, so we have to use product rule, u v prime plus v u prime. I wonder what happened. Wait. So I have u as sine x, v as ln of x, u prime would be cosine x, and v prime would be 1 over ln of x and chain rule, multiplied by the derivative of ln of x, which would be 1 over x. So if we plug that in the rule, we have sine x times 1 over x plus ln of x multiplied by cosine x. Now we have all the terms in order, and we could go ahead and plug it in this huge expression that we have for the second derivative. So y double prime divided by y minus one over y squared y prime squared equals the first term, which is the derivative of cosine x divided by x times ln of x, which is right here. I'm going to plug that in. You probably would not have a problem like this on the exam, but this is a problem for a good amount of practice. If we patiently understand, we could learn a whole lot of rules here. The quotient rule, product rule, chain rule, everything comes into play. So that is the first term, first derivative, and we have to replace the second part now, which is this, and we found the derivative of that here. So minus sine x over x plus ln of x multiplied by cosine x. We want to solve for the second derivative, so what I'm going to do is I am going to move that term to the other side. So y double prime divided by y would equal to y prime squared over y squared plus x ln of x sine x minus cosine x multiplied by 1 plus ln of x divided by x ln of x squared minus sine x over x minus ln of x times cosine x, and multiply by y on both sides. So the second derivative is y multiplied by that huge term y prime squared over y squared plus x ln of x sine x minus cosine x times 1 plus ln of x divided by x ln of x squared minus sine x over x minus ln of x times cosine of x. And that would be the final answer. We don't want to simplify it further. It's only going to get extremely painful, so we would leave it as is. As I mentioned, I am not going to put a problem like this on the exam because it'll be quite complicated. I'll put a note here. The second derivative is quite complicated, and you will not see it on the exam. And I should also note, but this problem is good for practice. You could learn chain rule, you could learn implicit differentiation, product rule, quotient rule, and so forth.